This lesson is to help you brush up on your simplification of radicals. There are a couple of ways you can do it, and so I'm going to start with the method that I'm going to call finding the roots. And so for the blue side over here, notice that all of these are square roots. When a number is not written here, you can assume that it really is a 2 because you're looking for square roots. So what I'm going to think about when I see this 12 is what perfect squares divide into 12 evenly. And perfect squares would be 1 squared is 1, but that one wouldn't help me. 2 squared is 4, 3 squared is 9, 4 squared 16, 25, 36. So these types of numbers are the ones that I'm looking for. 4 divides into 12. So 4 times 3 is 12, and 4 is my perfect square. So the square root of 4 is 2, so the square root of 12 would be 2 square root 3. Okay, for number 2, again, I'm looking for squares, and I know that 4 times 3 is 12. 4 is my perfect square. The square root of 4 is 2. But this time I have this 3 outside my radical. And so when I bring my 2 out of the square root, I'm going to multiply those. So it would be 6 square root 3 as my final answer. Now number 3 is a little more difficult. I'm having to think, okay, what numbers will divide into this thing? Well, at first it looks like maybe 16 will, but it won't. So I'm just going to use 4. If I divide 4 into 168, I get 42. Well, 42, none of my perfect squares divide into 42, so I'm just stuck with it. So the only perfect square that divides into 168 is 4, so that one's just going to be 2 square root 42. Now over here with the orange problems, I'm looking for cube roots. So now I'm going to be looking for perfect cubes. So if I list some perfect cubes, 2 cubed is 8 because 2 times 2 times 2 is 8. 3 cubed is 3 times 3 times 3, which is 9 times 3, which is 27. 4 cubed would be 4 times 4, which is 16, times another 4, which is 64. And then 5 cubed, 5 times 5 is 25, times another 5, 125. So these are the types of numbers that I'm trying to think about when I'm simplifying a cube root. Okay, which one of these would divide into 56, if any? And I see right away that 8 would. 8 times 7 gives me 56. The cube root of 8 is 2, so this answer would be 2 cube root 7. Again, very similar to the one that we did with the square root. 8 times 7 is 56. 8 is my cube root, that's what I'm looking for. And so I have 3 times cube root of 8 is 2, and I'm left with the cube root of 7. So I end up with 6 cube root 7. Now 168 is a little different. 8 will divide into it. It would go, let's see, 8 will divide into it 21 times, and 21 is 3 times 7, and neither one of those are perfect cubes. So again, 8 is my perfect cube. 2 cubed is 8, so that's why the 2 goes on the outside, and 21 is left on the inside. I have another method that I want to show you that you may like better. Okay, so again, I'm looking for square roots, but this time I'm going to look at my prime factorization. So I'm going to look at 12. 2 will divide into it 6 times. 2 will divide into it 3 times. And you want to divide down until you have a 1. Now, remember that a square root, you're looking for basically pairs. So here's a pair of 2's. So I know that 1, 2 is going to come out. So it would be 2 square root 3. So this one you would just have 3 because you have the 3 on the outside. Otherwise it's the same problem, 6 square root 3. And then down here with the 168, I know 2 will divide into it, and I'm only using prime numbers here. And again, I'm dividing all the way down using only prime numbers on the outside until I get to 1. And again, this is a square root, so I'm looking for pairs. The only pair I have is the 2. So I would rewrite the square root of 168 as 2 square root, and now I'm going to multiply all of these. 2 times 3 is 6, times 7 is 42. And I was doing these all square roots. And the way this changes is when I get over here to a cube root, now I'm looking for basically 3 of a kind. So if I look at 56 and I break it down into its prime factorization, I see it's even, so I can divide by 2. 2 goes into 5 twice with 1 left over, so it's 28. I can divide by 2 again. And again, I'm dividing till I get 1. I'm looking for 3 of a kind, and I notice I have 3 of a kind. So I have a 2 that's going to come out, so that answer would be 2 square root 7, the 7, or cube root 7. The 7's left inside. So here I know because that 3 is on the outside, I need multiplication, so it will be 6 cube root 7. And then here we did the prime factorization of 168 over here. So this time, however, the difference is I'm looking for 3 of a kind. Well, notice that I have 3 2's. So I'm going to have 1 2 that comes out because of those 3 2's. I'm looking for 3 of a kind because it's cube root. And I'm left with, this time, 7 times 3, which is 21. So the cube root of 168 would be 2 cube root 21. So both of those methods are legitimate methods for solving it. I usually use the first method that I showed you for smaller numbers because I do know what multiplies to give me 24. I know that 4 times 6 will give me 24, and 4 is a perfect square, so that would give me 2 square root 6. I also know a few things about cube roots, and I know 27 times 3 gives me 81, and 27 is a perfect cube, so that would be 3 cube root, and then the 3 is left inside. Now my 5s I don't know quite as well, but I do know that 2 to the 5th is 32. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And 32 times 3 would give me 96. So 32 is a perfect number to the 5th power because of 2 to the 5th. So I know the answer would be 2 5th root 3. Now for larger numbers, I just don't know that my multiplication facts as well, so I'm going to use the prime factorization method. So when I start breaking down 432, let's see what I come up with. And as long as it's even, I'm just going to keep dividing by 2's. And remember, you're going all the way down till you end up with 1. Okay, I'm looking for square roots in my first example, so I'm going to look for pairs. Well, here's a pair of 2, so that's 1 2 that's coming out. Here's another pair of 2, so that's another 2 that's coming out. I also have a pair of 3, so there's a 3 that's coming out, and I'm left with a 3 inside. So 2 times 2 is 4, times 3 is 12. So it would be 12 square root 3. Now I could check my work by kind of going backwards. If to get back inside the square root, this 12 would have to be squared. So here's my little check. I can go 12 squared times 3 and see if that works. 12 squared is 144. 144 times 3 is 144 times 3 is 12, carry the 1 is 13, 1 is 432, so it works. Okay, now for the cube root of 432, I'm going to list all of these. Here was our prime factorization. We had 2, 2, 2, 2. We had 4 2s, 1, 2, 3, 4, and 3 3s up here. I'm just copying this list. Now this time, because I'm looking for cube roots, I'm looking for groups of 3. So here are 3 2s, so that's a 2 that's going to come out. And here are 3 3s, so there's a 3 that's coming out. So this time I'm going to multiply 2 times 3, which is 6, and I'm left with 1 2. So it'll be 6 cube root 2. Now to check that one, I'm going to put everything back into the radical, but I have to cube the 6 to get it back in. Well, 6 cubed is 6 times 6 is 36, times another 6 is 216, and then if I multiply that times the 2, it is 432, so it checks. One other thing that I want to mention is about odd and even roots. For the unit that we're working on right now, until we get to equations, we're only going to be looking at the positive roots if we're looking at even. So when I ask you, like before, when you had the square root of 4, you would tell me plus or minus 2. But for the purpose of this unit, we're only looking at the principal root, which would just be the positive answer. However, things get a little more challenging when we have odd roots, so I want to point this out. For the square root of 24, I know that 4 times 6 is 24, so I can write that as 2 square root 6. However, can I find the negative square root? And that would require me to have like negative 4 times 6. And so I would be looking for the square root of negative 4, square root of 6. The square root of negative 4 is going to end up being an imaginary number. And for this unit, we're not dealing with imaginary numbers. So we would say that we can't solve that. For cube roots, for cube root of 24, I'm looking for things that are perfect cubes. So 8 times 3, the cube root of 8 is 2, so that would give me 2 cube root 3. My second example is what happens if I have the negative of 24. So the cube root of negative 24. Well, I could write that as negative 8 times 3. So this time I want the cube root of 8, cube root 3. Well, the cube root of negative 8, it could be negative 2, because negative 2 times negative 2 times negative 2 gives me negative 8. So I could write this answer as negative 2 cube root 3. So what I want you to learn from this is that when the number, your root number, is odd, you may have a negative. That's okay, because an odd number of negatives multiplied together gives you the negative. However, if the number is even, you can't have a negative, because an even number of negative numbers multiplied together gives you an even number. So without using imaginary numbers, you could not solve this. An odd root with a negative, good. Even root with a negative, no. Okay, I hope that helped you with your review.